Hi, this is Charlotte Cordell, and I will be talking about the science, engineering, and design video. This video was about a person who decided to he showed us how engineering works, mostly. Like, he showed the steps of the engineering process, how to apply them, and then how it actually works in real life. Like, how engineers start with it. And it's just keep in mind, it is a repeating pattern. It never ends. You can always improve it. So his example design process that he will be going with was the he observed the world around him, brainstormed solutions for a problem he had found, compared ideas, chose one, and decided to test that prototype. And if that prototype worked, he would continue on to the next step of um, making the final, which is the solution to this problem. So he decided to do this. Just keep in mind that they do background research and will learn as much as they physically possibly can before even starting the prototype and everything like that. They will do background research to test all types of different choices of what they can do. Consider a recipe is how he explained it, which I understood it really well that way. So it's like a recipe. It's you have these ingredients, you do these steps with those ingredients, and then you get this final solution, which is the final prototype, which you can always design to make better, no matter how many times you have redone it over and over again. So he started with making an observation. He paid close attention to the world around him to look for any problems that he might want to choose to fix, like by designing something. So he looked around, consider he said to consider looking around a school, walking outside, even at your house. He did these things and chose with walking outside. He realized that you can't play volleyball with one person and decided to try to make a prototype to solve that problem. So he decided with volleyball and okay, how do I make a two-player game, a one-player game that they can practice with? So he considered the facts that it has to be portable because you have to go outside to play volleyball, obviously. It has to work, obviously. And it has to be where you can leave it and continue on to the other side of the net. Because he was outside and realized, oh, you can't do it this way. So he decided, okay, I'm going to find a way to do it this way. Which I found interesting that of all choices, he chose how to play volleyball by yourself, which I found that really interesting because that's not something I would have thought of. So he started brainstorming solutions of how to do this. So he came up with, okay, these are the solutions. He even went with the basics of looking up services to help you practice, looking up coaches to help you practice. But then he decided, okay, I want to build a device. I don't want to go the first two. So he decided on 3 different devices he wanted to try. The kicking device to launch a ball, which he called the kicking volleyball launcher, a slingshot, or a pitching machine volleyball launcher is what he said in the video. So he decided to look through these 3. And then he finally went through it, looked to see which one was best, and decided to start with the kicking device instead of the other 2. So he started with the kicking device and chose that one as the first one. So he started making prototypes of this kicking device. They do quick prototypes. It's cost efficient. You can figure more details out about the solution before you actually physically build it. And it keeps things flexible so you can explore other options instead of having to stay on this one singular option. So he started with the volleyball kickball launcher and used cardboard and a hammer. And the hammer was the kicking force to hit the volleyball across the net. So he started by asking questions first about what he should be keeping in mind, which was Does my idea even work? Do I need to talk to users some more? Is it worthwhile to make a more refined, more expensive, and more time consuming prototype? And then he decided, okay, yes, this is worth it. So let's try it. He went into a higher ceiling room because obviously it's going to go up in the air if it works. And he tried it several different times. He didn't just try it once, he tried it over and over again. Like, he sped up the video due to it. And what he decided, the next section was, what did I learn from this? And it was, he needed to get the hammer to impact some more momentum onto the ball to launch it into the air. The ramp has to be designed well. It cannot be designed cheaply. It was really hard to transport from simply the room he was in into the high ceiling room. Better yet, into a car and then out onto a volleyball court. So he switched from volleyball to slingshot because it was just not working. And that's when he decided, okay, I didn't get it right the first time, let's try something else, and decided to go with the slingshot. So he repeated over and over again to learn even more. So he finally built his final prototype. He kind of sped it up and made this wooden contraption of a slingshot to make it work. So his prototype was made of wood. It was more durable. He found out more about the slingshot solution through testing it and making a previous one. And it was more transportable in general, carrying it out to the volleyball court, which he showed us. And how it worked was elastic bands acted as a slingshot, and there was like a funnel in between it. And it had 2 posts on the side. So after the hook will connect, the hook on the bottom of the elastic band will connect to this pin that goes through the side of it, the side of the base of the contraption. And when the pin gets removed, the ball will sling. The ball goes into the funnel between the elastic bands. And that's how it would work. After testing it, it worked, but it could have been improved as well. And this again, like I said at the beginning, the design process is repetitive, it's iterative, it's never ending. Like how we did the experiment today and stuff like that. So this is the end of science, engineering, and design. Thank you.